Dear students, good morning. How are you? I am your physics teacher, Shafiq Malik, from Pakistan International School, Doha, Qatar. As you know, this is our 9th week and lesson 2 of blended learning. In our previous lecture, we studied some topics of chapter number 7, electricity and energy. Today we will discuss more topics of this chapter. Therefore, all of you please open your science book, page number 100. Learning objectives. At the end of this lesson, students will be able to describe how electricity is generated by energy from fuels. Recognize possible environmental effects of the generation of electricity. Dear students, today our first topic is energy for everyday use. Most of the world's energy comes from 5 main sources. Number 1, oil, number 2, coal, number 3, gas, number 4, water, number 5, nuclear fuel. Electricity is not included because all electrical energy comes from other sources. Electricity is produced in power stations. First, we will discuss thermal power stations. Power stations which convert the energy from fuel into electrical energy are called thermal power stations. Most countries produce their electricity from coal, oil and gas. The fuels are used to heat water to produce steam. These steam turbines turn generators which then produce the electricity. This slide shows you the steam turbine and generator in a thermal power station. Now we will discuss the different parts of a thermal power station. On the left side of this slide, first of all, heat from coal, oil, or uranium, turns the water into steam in the boiler. This steam turns the turbines, due to which generator makes electricity. Transformer changes the voltage. During this process, steam is cooled in cooling tower. Lastly, with the help of power lines fitted on poles, this electricity is transferred to different cities. Dear students, did you know that 1 kilogram of uranium can produce as much energy as 60 tons of coal? It means that if we use 1 kilogram of uranium during fission reaction, then we will get same amount of energy if we burn 3 million kilogram or 60 tons of coal. That is, 1 kilogram uranium is equal to 3 million kilogram coal. 1 kilogram of uranium or 3 million kilogram of coal will produce the same heat. Dear students, we use uranium to produce electricity in nuclear power station. Now our next topic is hydroelectric power station. Power stations which convert the gravitational potential energy of water into electrical energy are called hydroelectric power stations. Hydroelectricity is produced from the gravitational potential energy of water stored high up in mountains. When this water is released, it turns water turbines which then turn generators which produce the electricity. Now we are going to discuss parts of hydroelectric power station and how it works. This slide shows that we store the water at height as a reservoir. This water has gravitational potential energy. The water falls through control gate on turbine. This water rotates the turbine, due to which generator makes electricity. Transformer changes the voltage. At last, with the help of power lines fitted on poles, this electricity is transferred to different areas. Dear students, as energy has many benefits, but there are some demerits during its production. Let's discuss energy production, the bad news. The production of energy is not risk-free. Whatever form of production is used, there is always an argument against it. Efficiency problems. Thermal power stations waste more energy than they produce. Most energy is lost as heat energy in the cooling water and waste gases. For example, the efficiency of a typical coal-burning power station is only about 35%. Only about 35% of the energy in its fuel is changed into electrical energy. The Sankey diagram shows what happens. On the left side of this figure, first of all, input energy from the fuel, loss in boilers, then some amount of energy loss in turbines. After that, energy is also lost in generators and to run power station. At the end we get output energy from generators in the form of electricity. Engineers try to make power stations as efficient as they can, but it is impossible to use all of the heat from the fuel to produce movement of the turbines. More bad news. Unfortunately, there are many more disadvantages to energy production than the inefficiency of power stations. Burning fossil fuels produces acid rain and carbon dioxide. Water from power stations, warmed during energy production, is often dumped into a local river or the sea. Increased water temperatures can cause serious changes to these ecosystems. Dear students, these pictures show you acid rain and water from power station change the ecosystems. This aerial photo shows the increased temperature of the water leaving a power station. The version on the right shows hot water as white and yellow, and cooler water as red. Another example of waste thermal heat energy being released into the atmosphere, which causes air pollution and acid rain, as shown in this figure. Dear students, did you know? In some areas, the warm water produced in power stations is used to heat buildings and homes close by, which is much better than harming the environment. It means we can use this warm water for useful purpose, instead of wasting it. Homework. Dear students, please note down your homework. Learn the topics taught today. Write down the answers of all parts of test yourself questions on your notebook. Solve the given worksheet. Write down the answers of all short and long questions on your notebook. I hope you have understood the topics taught today. Thank you and goodbye.